1 million households in the United States are already using indoor garden systems. Here's what it means. These households are now capable of growing a significant portion of their own food, reducing their reliance on industrial agriculture and lowering their carbon footprint, all while having fresh produce available year-round, a luxury that was once exclusive to those with large outdoor gardens. But now, with the advent of indoor garden systems, it's possible to have a backyard's worth of greens and vegetables in your house, with some systems capable of producing up to 200 pounds of produce per month, a staggering amount considering the average American consumes around 30 pounds of produce per month. This immediate consequence is crucial because it not only affects the individual households, but also has a ripple effect on the entire food supply chain. What does this mean for the future of food production? Can we really rely on indoor garden systems to feed the world's growing population? According to the news story Best Indoor Garden Systems, I've been testing all year, published in 2026. The author has been testing various indoor garden systems, specifically vertical hydroponic gardens, which have been gaining popularity in recent years due to their space-saving design and high yield. The author's test results show that some systems can grow up to 50 different types of plants, including leafy greens, herbs, and vegetables, in a single unit, with some systems using as little as 10% of the water required by traditional farming methods, and with an average crop cycle of 20-30 days, compared to 60-90 days for traditional farming. This is a significant reduction in water usage and increase in crop yield. But what's the actual cost of setting up and maintaining one of these systems? And how does it compare to the cost of buying produce from a grocery store? The technical facts behind these indoor garden systems are fascinating. For instance, did you know that some systems use LED grow lights that are specifically designed to emit a spectrum of light that is optimized for plant growth, with a color temperature of around 5000-6000 K, which is similar to natural daylight, and with an intensity of up to 40 watts per square foot, which is significantly higher than the 10-20 watts per square foot of traditional fluorescent grow lights, and with a lifespan of up to 50,000 hours compared to 10,000 hours for traditional fluorescent lights. This means that the LED grow lights can last for up to 5 years, with an energy consumption of around 100-200 kWh per month, which is relatively low compared to other household appliances. But what about the nutrient delivery system? How does it work? And what kind of nutrients are used? According to the article, some systems use a nutrient film technique, which delivers a constant flow of nutrient-rich water to the roots of the plants, with a pH level of around 6.0-6.5, and with a nutrient concentration of around 100-200 ppm, which is relatively low compared to traditional hydroponic systems, and with a water circulation rate of around 1-2 gallons per minute, which is significant considering the small size of the system. The real impact of these indoor garden systems is that they can provide a significant portion of a household's produce, with some systems capable of producing up to 50% of a household's annual produce needs, which translates to around $500-$1,000 per year in savings, and with the average household spending around $1,000-$2,000 per year on produce. This means that indoor garden systems can provide a significant return on investment. But what about the environmental impact? Can indoor garden systems really reduce our carbon footprint? According to the article, some systems can reduce water usage by up to 90%, and with the average household using around 100-200 gallons of water per day. This means that indoor garden systems can save around 30-60 gallons of water per day, which is significant considering the droughts and water shortages that many parts of the world are facing. And with the average household producing around 100-200 pounds of CO2 per day, indoor garden systems can reduce this amount by up to 20%, which is a significant reduction considering the current climate crisis. The single most surprising insight from this article is that indoor garden systems can be used to grow a wide variety of crops, including leafy greens, herbs, and vegetables, with some systems capable of producing up to 200 pounds of produce per month, which is a staggering amount considering the small size of the system. But what does this mean for the future of food production? Will indoor garden systems become the norm, and will they be able to feed the world's growing population? Can we really rely on these systems to provide a sustainable and reliable source of food? Follow for daily AI and tech news to stay up to date on the latest developments in indoor garden systems and other emerging technologies that are changing the way we live and work.